All right, students, it's time to take a look at our investigation from last week, the simplification investigation. Hold on to your neurons, people. Prepare to have your minds blown. All right, so in the investigation, we were looking at what some kids came up with as rules to try to make it easier to simplify fractions. So one of the kids came up with this statement: if a fraction has one prime number, it can never be simplified, or at least that's what the kid claimed. So we're asking, is that statement true? Is it really true that if a fraction has a prime number, you can't simplify it? Worth thinking about. So let's try some examples. But before we do, here's a word from our sponsor: randomness. It's what you do when you don't know what to do. So in investigations and activities like this, any big project or big task, if you don't have a plan, sometimes people jump randomly and just start trying things, and there is some value in that. But I'm going to warn you that in math and in a lot of other things, that's a fast way to start wasting your time. Randomness and just trying things at random, if you're not paying close attention, doesn't have much value. So it's better to have a plan. You don't want to waste your time on random attempts to figure out the answer to a problem. So my advice is make a plan and start simple. So let's think about it. If a fraction has one prime number, it can never be simplified. At least that's what they're claiming. So let's list prime numbers. Now we're not going to list all of them because they go on forever. But here are some early ones: 2, 3, 5, 7, 11, and 13. So those are your basic early prime numbers. And we'll use those as at least a starting point to see if you can really not simplify a fraction that has one prime number. So we're going to start with the number 2. Like I said, have a plan and start simply. Does it have one prime number, and can it be simplified? So here's 2/3. Okay. Actually, we shouldn't use that. Why not? Because it doesn't actually fit with our experiment. Our experiment is, does it have one prime number, and can it be simplified? So that one shouldn't even count. So now we'll try 2 out of 4. Okay, so I have my prime number in the numerator, 2. And then I've got 4 as my denominator. 4 is not prime. So can that be simplified? Yeah, it can. So guess what? Just with that first example, 2 out of 4, we've now proven that just because a fraction has a prime number, one prime number, that doesn't mean that you can't simplify it. Or another way to say it is, if a fraction has a prime number, you might still be able to simplify it. So prime numbers aren't automatically a stopping point. But let's continue just to examine this a little further. 2/5. Okay, that one we shouldn't even count because, again, that's 2 prime numbers. That's not what we're investigating, and anyway, you can't simplify that. Here's 2/6. Can that be simplified? We've got the prime number 2 in the numerator, and then we have a composite number 6 in the denominator. Well, can you simplify it? Yes, you can. So there's just more proof that just because a fraction has a prime number doesn't automatically mean that you're done with simplification. 2/7, they're both prime numbers, so we shouldn't even use that as an example. All right, now let's try it with the number 3. What do you think the first example should be that we would try? What fraction? Hopefully you said 3 out of 4. Can 3 out of 4 be simplified? No, it can't be simplified. There's 3 out of 6. Can 3 out of 6 be simplified? Probably you're saying yes right now. It simplifies to a half. So that is another example of a fraction that proves that that kid was not right. 3 out of 8. Well, that one works for the kid, but we've already basically decided that his rule doesn't work. So just because 3 out of 8 can't be simplified, that doesn't really prove his point anymore, since we have 3 examples so far that go against his examples. 3 out of 9, yes, that can be simplified, and then 3 out of 10, no, it can't. Now we'll just try it one more time with the number 5, just to investigate a little bit further. All right, does it have one prime number, and can it be simplified? So what's the first fraction that uses a 5 in the numerator that we should try? 5 out of 6, right. And that cannot be simplified. How about 5 out of 8? One of those is prime, the other one isn't. Can that be simplified? No. 5 out of 9. Can that be simplified? No. Uh-oh. 5 out of 10. Can it be simplified? Yes, it can. So even that one helps to prove that even because it has a prime number, like the number 5 out of 10, or fraction 5 out of 10, just because there's one prime number doesn't mean you can't simplify it. Okay? 5 out of 12? No, can't simplify it. So was the kid right? If a fraction has one prime number, it can never be simplified. That's what he claims. Is he right? Afraid not. At least not in the examples that we found. So here's my question though. Did we overlook anything? Were there any possibilities that we didn't consider? Give that some thought. The answer might surprise you.